Hi students, today you are going to learn back face detection. And back face detection is a type of visible face detection. In the last video, we have studied a visible face detection and two approaches of visible face detection, that is image space method and object space method. Today we are going to learn different types of visible face detection or type of visible face detection methods. First one is back face detection. From the name itself, it is clear that back face detection. What is that? Back face has to be detected and removed. That is, back face detection can be used to solve hidden surface problems. Okay. And about the back face detection, it is an example of object space method. As we have already discussed, object space method is a method that is implemented in physical coordinate system, that is our Cartesian coordinate system. And in a solid object, there are surfaces that are facing the viewer. And those surfaces that are facing the viewer is called front face. And the surface opposite to the viewer, that is the surface that are not able to see by the user, are called back face. We can say that normally half of the total number of surfaces are mostly back faces. And removing back part of the part of an image for saving the processing time, we can remove before the clipping process. So in order to remove the processing time, we can remove these back faces of an object before the clipping process. And a fast and simple object space method for identifying back faces of a polyhedron is based on an inside outside test. It is a simple and fast method. We all know that a polygon surface with parameters a, b, c and d is represented by the parametric equation ax plus by plus cz plus d is less than 0. That is, if we take a point x, y, z and it is ax plus by plus cz plus d is less than 0, that point is inside the polygon. So a point xyz is inside the polygon, we can say that it cannot be seen by the user. So it is the back side of the object and we can remove it. And the second approach is, suppose a surface is back, then the v dot n is greater than 0. What is v and what is n? V is the viewer vector, or that is the viewing direction from the eye position of the viewer, or the viewing direction from a camera. And n is the normal vector. It can be seen in this image. If this is our 3D object and this is a camera, we are going to take the photograph of this 3D object. This is our vector v. Okay, that is it is in the direction of the camera, viewing position of the camera, and this is the, if we are considering this surface, this is the n vector, that is, it is a vector that is perpendicular to the surface that we are taken. And the if A, B, C and the Cartesian components, the V can be represented, the vector V can be represented by 0, 0, Vz. That is, as we are viewing in the positive z direction, the x and y coordinate will be 0. So the V can be represented as, vector V can be represented as 0, 0, Vz. And we can say that V dot n is equal to Vz dot Cz. So if the V dot n is greater, if we want the V dot n to be greater than 0, the sign of the C should be greater than 0. If the sign of the C is that is, if C is positive, it is back face, and if C is less than 0, it is front face. And the advantages of this method are, it is a simple and straightforward method, and also it reduces the size of the databases. These are the advantages of back face detection method. Thank you.